Okay, welcome, people of Earth, to day 21 of the 2021 Advent of Code. Um, I gotta admit, this is kind of the around the time every year where I start to get a little tired of this thing. I mean, I still do enjoy it once I get into it, but 3 weeks is kind of a long time to have this appointment every single night, and and it does, yeah, it kind of wears me out. And also, as I said before, it throws off my sleep schedule because I can't get sleep for a couple of hours after I do this because that's just the way I'm wired. It's not a good time of day for me to be working. But anyway, and I mean, this is really compounded. Sorry, let me turn off my noisemaker here. This is compounded by last night. I didn't do very well. I kind of knew I was not in the mood for it going in, and of course, having a bad night doesn't really energize you for the following night. So there's a big part of me that's hoping that tonight's is kind of an easy one, or at least one that I do very well on, so I kind of get my motivation back for the last 4 days. So we can look forward to that, but we might as well reflect on some of the details from yesterday. Um, I mean, watching the video of myself, which I did, and was a little tedious. Not the best video I've made, I think. It only took about 10 minutes to get the basic logic down, and in hindsight, it's really only about 20 lines of code, and it's always kind of shocking that you can take a full hour of like moderately hard work to come up with 10 lines of code. But that's 20 lines of code. Um, but, that's just the way it goes. um, uh, my hack with adding margins, just adding little things on the end. Um, well, there are a couple of different things to say about that. Um, it ended up probably being more complicated and more code than just doing the virtual infinite grid that I kind of ended up implementing. And also, I think I mentioned it farther down in the reflections, if I had really thought it through, what I could have done is just added, well, I probably would have had to figure out the trick to realize the second part of this, but I probably could have added all the margins I needed right from the beginning and then just simulated as opposed to adding margins each time. And that also would have been a lot simpler. So, I wasn't super clear headed about any of this last night. This morning it all became a lot more clear, right? Um, and that was my main thought watching the video of myself is that it's so obvious once you know, right? Um, because as soon as I saw, visualized, these cellular automata, which is really what we were building, um, it became clear that something weird was going on at the edges for the real problem, not the sample input. And like that's the first thing I said is that the edges are doing something weird, and yet it didn't like twig with me to follow that up. And it took about 40 minutes for me to recognize something that I really should have checked from the start because it's kind of an obvious sanity check. If you're going to just assume that the empty space stays the same, you need 0 to map to 0, right? And it didn't. 0 mapped to 1 and 1 mapped to 0. And it took me 40 minutes to realize that 0 mapped to 1. And then I didn't even think to check what 1, well, not 1, but 511 or whatever, all bit set, then actually mapped to no bit set or to 0. And then you just apply that everywhere. So it means no bit set. And, so it was like it was 50 minutes, almost, when I finally realized the second half of why this was so fundamentally different than the test data. That on every cycle, you effectively inverted the infinite plane, right? And once you, like so many of these problems, once you recognize what the real problem is and what's going on, it's not super complicated. Then there are plenty of options for solving it. It's just a matter of picking one and going with it, right? Um, I do take one tiny issue: the framing of this problem, which is always a conceit. It's always about elves and submarines, and so it's always nonsense. But this kind of we're doing something to an image, and the fact that it's flashing back and forth on every iteration really does conflict with the framing. So the framing isn't just like an adjunct; it's downright misleading in this case. I realize this is like the second day I've complained about the framing of the problem, and that's just bad sportsmanship because I think it was a perfectly valid problem, and I just did badly at it. Anyway, let me see. Could have made the margins all up front. Oh, also, I kind of kept going about the border. You needed two because I was thinking there were three around, but actually you only need a border of one because the only square that you're, the only position that you're caring about, it only cares about its immediate neighbors. So you only need to add a border of one to get this to work. I think. I haven't tested that, but that's just, upon watching it and having programmed it last night, these are all the things that seemed obvious in the cold light of day. And I did have the question last time about how long it would actually take to run if I ran Optimus. It was about 3 minutes to run my incredibly naive, unoptimized solution that was actually making these things bigger than they needed to be because I was adding 2 on each side, so that's 4 total, which makes a considerable difference because the 50th iteration was much slower than the first iteration, and it would have been only half as much slower, if you see what I mean, if I'd only added 1 every time I did this. But even so, it was only 3 minutes, and for me at least, programming almost any optimization will take me at least 3 minutes. So, and this did work on the 50 iteration thing. I ran it twice, but the first run, if I had let it finish, would have accomplished the same thing. So it's not like I needed to run it multiple times. And there's this kind of rule of thumb about optimization that you should do an optimization if the total runtime over the entire history of the program will exceed the time that you're going to program. And sometimes they multiply it by 10. They say, if it's going to be 10 times more time that you'd spend programming it. And usually, this is all just a thought experiment because if you're putting something in a library that's heavily used, then it will be used a crazy number of times. But in this case, you're literally only running it once, so what's the point in optimizing is really the lesson here. I don't know if that's much of a lesson, but anyway, so let's move on to trying to solve, hopefully not too stupidly, day 21. Okay. Oh, this is going to be number theory. I hate the number theory ones. I don't know any number theory. What is my puzzle input? Well, no parsing. Okay. So, okay. Okay. What kind of a die? It doesn't say how many sides the die has. Maybe 6. Okay. Yeah. Okay. Ah. 100-sided die. Oh. Okay, and Okay. Um. Rolls. Yeah. Um. Ooh. Okay. Okay. Um. 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 Uh, 10, and they start at, they have 1 through 10. Let's just parenthesize this. I don't think you need to parenthesize this because precedence does it. Okay, and it ends when at least 1,000. I bet people have already finished this in 3 minutes, right? Um, oh, RP1 score. Okay. What do you get if you multiply the score of the losing player? Um, uh, oh, come on. Ah, why am I taking so much time? And I forgot the print from above, didn't I? So I still don't have my code finished. And we don't need that. Does it run? Yes. What is that? Come on. No. Oh, darn it. Oh, okay. P1 score, P2 score times rolls. Okay. If it's 4 and then 8. After many turns for a final score of 1,000. 7 through. Ooh, okay, so we got it wrong here. So, player 1. Let's go to the top here. What is all this? 0. Player 1 plus 2 plus 3. What? Roll 1. Player 1 is 1 plus 2 plus 3 is percent equals 0. Oh no, we should. What should we do? Oh no. Now what happens? 739, 785. Yeah, okay. So it was just an off by 1 error. Oh, it's so frustrating because we would have had a good time. But we didn't. I worry that the second part is going to require number theory to get there. 316. See, we probably could have had a good time. But, okay. Real game. Dirac dice. Oh, well, okay, so there are only, yeah, okay. How do I explain this? So, there can be, how many possible states can there be? And this is going to be a dictionary from. It's going to be very poorly documented, right? So, yeah, okay. Okay, so. So, okay, my states is going to be the score and position of each player. So 4 numbers mapped to the number of universes in which that state is true. That's what I'm doing. And so then I don't have to worry about the number of universes. I just care about the number of states. And there are a small number of states. There's like 21 times 10. There's a tiny number of there's 21 times 10 times 21 times 10. So not a lot of states, right? Okay. In 1 to 3, R2 and 1 to 3. Next key. So we change the player 1 things, and we're going to say that first is okay. Next pause is K0 plus R1 plus R2 plus R3. You %10. The new key is new pause, and then 1 plus, and what are we doing? the score is going to be that plus 1, K2, K3. My only chance is if other people haven't figured out a strategy as quickly as I have. So, this is again not the most efficient way to do this, but don't care because it's fast enough. Right. Roll. Okay. And then we have to do this. Well, okay, so what's our winning condition? So the game now ends when either player's score is at least 21. Okay. Now I do have to think this through for a moment. Okay, multiple copies. Okay. The game now ends. Using now the number of universes in which someone wins. Okay. So, if end score. Okay. Continue the okay. Yes, this is all good. So that's the current states, but we're changing each state. So no. End states. So then. Right. Yes. So those are the roles for first. Let's just comment all of this out because it's all crap. Then we do all this for player 2, don't we? K012, 3. Right. K0, K1, Okay. P2 score goes up by 1. States. Wait, what? No, this is not right at all. The updating of the states goes this the updating of the states goes elsewhere. For each one. All the possible states. Yeah, okay. So we do that for every. So player 1 goes for every possible state. And then equals n states. Oh. Then player 2 goes. Right. Okay. And that's their for loop. And now we're just in the while. And while states is empty. Ooh, let's see if this compiles. Oh, 0. Well, that isn't great. Oh, we do need to initialize states, don't we? States is, so what is it? First pause, then score? P1, 0, P2, 0. Oh, what just happened there? Yeah, because we need an extra set of things here. Now what happens? Well, it ran. Okay. Find the player that wins in more and how many universes. Which one of these is bigger? 4, 6, 8, 3, 3, 1. That looks bigger. So no. Oh, darn it. So what's our sample input? So using the same starting is in the same one. So that's 4 and 8. Oh no. I can explain that because we don't just do that. No. P1 score. No, both of these are not 1s, they're V's. Okay. Now what? Okay, that makes more sense. Um, what's part two? In 444. Yes, okay, back to our original thing. We wrote the logic. We were moderately quick today. What were we? 300 something in the first part. The second part, let's see how well other people did, because that's the real question. Um, um, you know what? I can't even compare numbers, so let's just do this. I couldn't count the number of digits. I really couldn't. Um, I wish there were an easy way to put commas in things, but putting commas in numbers is actually quite hard for computers. See, this one has more digits, but I wouldn't have guessed that. And that would have locked us out for a minute. So, okay. 143. So, we did fine today. Just to reinforce the logic we used for all this. Um, uh, I realize how obscure this is when you're not naming any of your variables. This is a 4-element array. The first element is player one's position. The second is player one's score. The third is player two's position. The fourth is player two's score, right? So there are only 21 times 10 times 21 times 10 possible states, right? And this is the number of universes in which that state exists. So every turn, what we just do is go through all the states, and then player one plays, and then we create, and we see how many universes. And then every possible subsequent state, we count how many universes that state is true in, right? And then player two goes, and we do the same thing, and we do that and when someone wins, that's not a state we're going to keep considering. We just add the number of universes in which they won to the score, and then when there are no more states still being played, we're done and we have our numbers. So that was our strategy. Took 20 minutes or something. How long did it take the best people? The second one, so just over the score, the leaderboard filled up in just under 21 minutes. How did I do 21 minutes? And I took a couple of minutes longer than that, which is about appropriate for my rank, I guess. If we hadn't screwed up in the first half, well, it still took us 15 minutes for the second part there. But anyway, okay, this was fun, required a little bit of thought, and I'm very satisfied with how I did. So I think tonight went well. Anyway, I'll